National Electrical Code Article 517.19c3 addresses electrical requirements within specific patient care locations. This section of the code directly relates to intensive care units and other areas where electrical isolation is deemed necessary for patient safety. Specifically, the code stipulates that if electrical isolation is required in a patient care area, then all electrical outlets and any other electrical equipment within that space must be connected to the isolated power system. This means that any standard grounded outlets present alongside an isolated power system within such a room constitutes a code violation. The primary goal is to maintain a consistent level of electrical protection throughout the patient care area, minimizing the risk of electrical shock or other hazards. A straightforward solution to this code violation involves connecting all electrical outlets and electrical equipment located within the intensive care unit to the isolated power panel. This encompasses both the outlets situated in the patient head wall and any outlets found in the perimeter walls of the room. By ensuring that all electrical points within the ICU are powered by the isolated system, the facility achieves full compliance with the National Electrical Code and provides a safer environment for patients and medical staff. Isolated power systems offer several key benefits that contribute to a more secure and reliable electrical environment. Firstly, these systems reduce noise and electrical interference. Secondly, they protect sensitive medical equipment from electrical surges and transients. Thirdly, and most importantly, they enhance patient safety by significantly reducing the risk of electrical shock. The implementation of isolated power involves several essential steps. Initially, a separate isolated power panel must be installed. This panel is then connected to a dedicated isolation transformer, which provides the necessary electrical isolation. All electrical outlets and equipment within the ICU room must be connected to this isolated power panel. Several additional considerations must be taken into account when implementing an isolated power system. Firstly, the isolated power system must be designed and installed in strict accordance with National Electrical Code Article 517 and any other applicable regulations. Secondly, it is imperative that the electrical contractor provides comprehensive documentation. This documentation should verify that the isolated power system has been properly installed, tested, and meets all required safety standards. Thirdly, regular inspections and maintenance are crucial to ensuring the ongoing proper functioning of the isolated power system. This includes periodic testing and maintenance to detect any potential issues or degradation of the system's performance over time. By adhering to these guidelines and ensuring proper implementation and maintenance, healthcare facilities can provide a safe and reliable electrical environment for patients and staff within intensive care units. The importance of isolation power systems in healthcare environments cannot be overstated. These systems provide a critical layer of protection against electrical hazards, particularly in areas where patients are most vulnerable. The NEC Article 517 addresses the specific requirements for healthcare facilities. Article 517.13 covers wiring methods, including the types of wiring allowed and the grounding requirements. Article 517.14 discusses the requirements for essential electrical systems which provide backup power in case of a power outage. Article 517.16 focuses on the grounding and bonding requirements for patient care equipment. Article 517.19 covers the requirements for isolated power systems in critical care areas. The design and implementation of isolated power systems require a deep understanding of electrical engineering principles, as well as a thorough knowledge of the applicable codes and standards. The isolation transformer is a key component of the system. It provides electrical isolation between the primary and secondary windings, preventing the flow of ground current. The line isolation monitor is another important component. It continuously monitors the impedance to ground and provides an alarm if the impedance falls below a certain level. The purpose of the line isolation monitor is to detect any potential ground faults that could pose a shock hazard. The proper grounding and bonding of the electrical system are also critical. Grounding provides a low impedance path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. Bonding ensures that all metal parts of the electrical system are at the same potential, reducing the risk of electrical shock. Regular testing and maintenance are essential to ensure the continued safety and reliability of isolated power systems. Testing should include insulation resistance testing, ground impedance testing, and line isolation monitor testing. Maintenance should include visual inspections, cleaning, and tightening of connections. In addition to the technical aspects of isolated power systems, it is also important to consider the human factors. Healthcare professionals should be trained on the proper use of electrical equipment and the potential hazards of electrical shock. They should also be aware of the location of isolated power systems and the procedures to follow in case of an electrical emergency. In conclusion, isolated power systems are a critical component of electrical safety in healthcare facilities. They provide a high level of protection against electrical shock and other hazards. The design, installation, testing, and maintenance of these systems require a thorough understanding of electrical engineering principles and applicable codes and standards. Ongoing training and education are also essential to ensure the safe and effective use of electrical equipment in healthcare environments. When evaluating the grounding system, it's important to consider that conventional grounding systems are designed to provide a low impedance path for fault currents, ensuring that circuit breakers trip quickly to energize a faulty circuit. Isolated power systems, on the other hand, are designed to limit the amount of current that can flow in the event of a single fault to ground. This is achieved by using an isolation transformer, which creates a separate, ungrounded electrical system. The line isolation monitor then detects any leakage current to ground, providing an alarm if the leakage exceeds a safe level. The combination of the isolation transformer and the line isolation monitor provides a high level of protection against electrical shock, especially in situations where patients may be particularly vulnerable, such as during surgery or in intensive care. It is essential that the design, installation, and maintenance of isolated power systems are carried out by qualified professionals who are familiar with the specific requirements of healthcare facilities. This includes ensuring that the system is properly grounded and bonded, and that the line isolation monitor is regularly tested and calibrated. The NEC provides detailed guidance on the design and installation of electrical systems in healthcare facilities, including specific requirements for isolated power systems. These requirements are intended to ensure the safety of patients and staff, and it is essential that they are followed carefully. The National Fire Protection Association offers a range of resources on electrical safety, including codes and standards, training programs, and public education materials. These resources can be valuable for healthcare professionals, electrical contractors, and anyone else who is involved in the design, installation, or maintenance of electrical systems in healthcare facilities. The NEC requirements are not static. They evolve based on technological advancements, new understandings of safety risks, and feedback from professionals in the field. Therefore, it is vital to stay updated with the latest revisions of the code. Healthcare facilities should implement policies and procedures for the regular inspection and maintenance of all electrical equipment, including isolated power systems. This should include visual inspections, electrical testing, and calibration of monitoring devices. Furthermore, staff should be trained to recognize potential electrical hazards and to respond appropriately in the event of an emergency. The benefits of isolated power extend beyond immediate electrical safety. It also reduces electromagnetic interference, which can affect sensitive monitoring equipment. It minimizes the risk of equipment malfunction due to power fluctuations, which can lead to inaccurate readings or interrupted procedures. Isolated power creates a more stable and reliable electrical environment, which is crucial for optimal patient care. Electrical safety audits should be conducted periodically to identify potential hazards and ensure compliance with applicable codes and standards. The electrical audit should be conducted by a qualified professional. The electrical auditor will look for potential problems. It is a good idea to hire the auditor. The electrical auditor can help to keep the environment safe. The electrical auditor will generate a detailed report. The electrical auditor will make specific recommendations. The design of an isolated power system must take into account the specific needs of the healthcare facility. This includes the size of the facility, the types of medical equipment used, and the number of patients being treated. The system must be designed to provide adequate power for all of the electrical loads in the facility, while also maintaining a high level of electrical safety. It is crucial to choose the right components for an isolated power system. The components include the isolation transformer, line isolation monitor, and grounding and bonding conductors. These components must be chosen to meet the specific requirements of the healthcare facility. The components must be reliable and durable. Proper installation is important. This must be installed by qualified professionals. The installation must follow all applicable codes and standards. The isolated power system is critical. This protects patients and staff from electrical shock. These systems provide a reliable source of power. They help ensure the safe operation of medical equipment. Regular inspections and maintenance are essential for the continued safety and reliability of isolated power systems. The inspections and maintenance should be performed by qualified professionals. The inspections and maintenance should include visual inspections, electrical testing, and calibration of monitoring devices. By taking these steps, healthcare facilities can help ensure the safety of patients and staff and the reliable operation of medical equipment. The NEC provides requirements for healthcare facilities. Those requirements are in Article 517. Article 517 is in the National Electrical Code. The National Electrical Code is updated on a regular basis. Healthcare facilities should also consult with qualified electrical engineers and contractors to ensure that their electrical systems are designed, installed, and maintained in accordance with all applicable codes and standards. Isolated power systems play a critical role. They play a role in providing a safe and reliable electrical environment for patients and staff. Healthcare facilities should implement comprehensive electrical safety programs. The electrical safety programs can help to minimize the risk of electrical shock and other hazards. The electrical safety program should include regular inspections, testing, and maintenance of electrical equipment. Also, the programs should include training for healthcare professionals and the proper use of electrical equipment and the potential hazards of electrical shock. It is vital to prioritize electrical safety in healthcare facilities.